Okay, so one of the ways that we can use the log rules is to rewrite a log of some big complicated expression with lots of multiplication and lots of exponents as a combination of much simpler logs. Now, when they were invented, this was actually the core use of logarithms, because if you don't have a calculator, well, addition is much, much easier than multiplication if you're working with big numbers, right? If you're adding big numbers, you just work down the columns. Whereas if you're multiplying big numbers, you have to do the thing where you have every digit multiplied by every other digit, and it takes forever. So you would just get a table of logarithms, or later on you would get a slide rule, and you would look up your big numbers in your table of logarithms, and then you would add the logarithms, and then you would look up the result, and you would get the product of your big numbers. In the 21st century, that is no longer a core use of logarithms, because we have calculators now. However, it turns out that making this move to split up logarithms is also very, very useful if we're keen to do calculus, because doing calculus to sums and differences is much, much easier than doing calculus to products and quotients. Doing calculus to something that's multiplied by a number is easier than doing calculus to something that's raised to some power. So this is still useful in the 21st century. We just use it in different ways. How do we use it? First, I'm going to mention that we're going to just assume that everything we've written inside a log is positive. Right? We'll assume that there are no worries about the domain. The variables have whatever restrictions they need to have on them. We have a rule that lets us split up products and quotients, and a rule that lets us pull out powers. What we don't have is a rule that lets us split up sums. So what that means is that if we have addition, and that includes subtraction. Remember, subtraction is just addition in disguise. If we have addition or subtraction inside a log, we have to leave it alone. Here we're going to use our log rules to rewrite this log of a big complicated expression in terms of the simplest possible logs. So our first step is, notice we have a square root here. This might be a little bit tricky to see. This 4 is connected to the x to the 4th. This is not a 4th root here. You can tell because the 4 is not inside the crook of that radical there. So we have a square root there. The first thing we're going to notice is that that's actually an exponent in disguise, right? The square root is really the 1/2 power. So our first move is just going to be to rewrite this whole expression, but write the 1/2 power instead of the square root. And now we're going to use our log rules following order of operations backwards, right? We're undoing something, so we're going to reverse the order of operations. Order of operations, that fraction bar acts as a grouping symbol, so the last thing we would do in evaluating that would be to do the division. The first thing we're going to do is split up that quotient. So we've got our numerator here. We'll have the log base 7 of our numerator. And then this is a quotient, so we'll subtract. And then we have our denominator, so log base 7 of our denominator. Okay, now within each of those logs, we have a long product, right? We've got a bunch of multiplication in there. So each of these terms we can split up using the log of a product rule. First term we'll split up as the log of 2 plus the log of x to the 4th plus the log of x minus 4 to the 1/2. And then the second term splits up as the log of y to the fifth plus the log of z. And notice that those were single terms before. When I split them up, I needed to put them in parentheses. I put them in brackets just so that we wouldn't confuse the brackets with the earlier parentheses, right? And the reason that I needed those is that notice we have this subtraction. Each of these terms is going to end up negative. So that's what we'll do now. We're going to get rid of those brackets. These first three terms are going to stay positive. And then these last two terms are going to be negative. So we'll have a minus log of y to the fifth minus log of z. Okay, and now the last thing we need to do is deal with the exponents, right? We'll use the log of a power rule to pull the exponents out front. So log of 2 stays the same. Exponent 4 gets pulled out front. We'll have 4 log of x. Exponent 1/2 gets pulled out front, so we'll have 1/2 log of x minus 4. Exponent 5 comes out front, so we'll have minus 5 log of y. And then no exponent here, so log of z stays exactly the way it is. And now we've rewritten our expression using the simplest possible logs, right? We have a log of 2, a log of x. A log of x minus 4, but remember we can't do anything with addition or subtraction inside a log. A log of y, a log of z. That's as simple as it gets. Okay, you might be wondering, is there a shortcut here? And the answer is that yes, there is a shortcut here. There is a shortcut that will let us jump straight to this line. And that is that factors from the numerator give us positive terms, and factors from the denominator give us negative terms. So let's see how we can use that shortcut to rewrite another one of these big complicated expressions. We see that we have 1, 2, 3 factors in our numerator, and we have 1, 2 factors in our denominator. So we're going to end up with 5 terms, 3 positive and 2 negative. Looking at the numerator, the first factor is a 3, so we'll have a log of 3. The second factor is x minus 1 all to the 5th, so we'll have a log of x minus 1 all to the 5th. The third factor is a cube root of y. That means y to the 1/3. So we'll have a log of y to the 1/3. So those are all positive terms coming from the numerator. In the denominator, we have a z to the 4th. So we'll have minus log base 4 z to the 4th. And then we have y plus 1 take the square root. The square root means the 1/2 power. So we'll have minus log of y plus 1 to the 1/2 power. So that was using the product rule and the quotient rule and distributing a negative sign and rewriting radicals as exponents. Right? We combined a whole lot of steps here, And usually I'm not in favor of doing that. Usually I'm not in favor of taking these kinds of big shortcuts. But in this case, the shortcut is just so much easier that I actually recommend using the shortcut in this kind of problem. Our last step, we're just going to use the log of a power rule. So we have these exponents. And they're going to become coefficients. So the log of 3 just sits there. The log of x minus 1 to the 5th is going to become 5 times the log of x minus 1. The log of y to the 1/3 is going to become 1/3 times the log of y. The log of z to the 4th is going to become 4 times the log of z. And then the log of y plus 1 to the 1/2 is going to become 1/2 of the log of y plus 1. And there we go. After you practice this 50 times or so, you might find that you're able to just write down this last line directly, but practice starting with this line first. In general, it's not necessary to go through the whole long process. Factors in the numerator give positive terms, factors in the denominator give negative terms, and you can use that to split up the entire fraction right away.